Okay, blue marble. This is our topic for today. Now that we're ready for doing an activity. Okay? So we're going to turn the lights on. I'm going to bring my son to the front, and you are going to play like you're a student. Okay, now the first thing I want to do is, can we plug this in? This is going to be a little bright light, all right? But don't look at it directly. You don't ever want to look at the sun. Okay. Here's our light. Now, if the sun is the center of our universe, correct? Everybody agree? What is the appropriate position of the Earth relative to the sun? All right? Is it straight up and down? Is it tilted? What do you think your students would say, and how would you begin to orient it? In order to understand the Earth system, the place to start is its relationship to the sun. The Earth itself, we treat as a closed system. That means what's here stays here. That's only sort of true, okay? Because we do get comments coming from way out there, okay? And we do get energy coming from the sun. And it's that energy that drives a lot of the changes in this in this Earth. Okay. So now I'm going to hold it like this. Do you see that it's tilted? That means that this ball is rotating. Now, the first thing you have to remember is which direction is it turning? When somebody volunteer me for the group, how do you always remember which way the Earth is turning? What guides you? It's only got two ways. You can either go right or left, all right? What is a way that you can remember instantly in your classroom which direction this thing turns? Anybody got an idea? What do you say? Opposite of a clock. Okay? That's very good. Anybody ever think about the direction that the sun appears in the morning? Okay? Which way does the sun appear? I think clockwise is fine, but I'm more interested in our students understanding their world. Okay? And when they're running around outside, clockwise doesn't mean a whole lot. I think you need to make sure in your classroom that your students know in the classroom which direction is north, south, east, and west, where their home is, what direction is north, south, east, and west, what direction the sun comes up. And if you don't have them do a year-long log about that sort of thing, you could do it every year. Don't worry about it if they did it in first grade or if they did it in third grade or if they're doing it in fifth grade. Have them be aware of those changes. Okay? So now here we go. I'm going to say that from where I am here in Houston, Texas, okay, the sun comes up on the East Coast first. So if that's the sun, it's going to have to come around here. It's going to have to get there first, okay? I don't care what you come up with, but you need to devise a system that's going to work for you, okay? How long does it take the Earth to go all the way around one time? 24 hours, and we call that rotating, right? Does the Earth move relative to the sun? Okay, you're nodding your head. How does it move? It goes around. We call this orbiting. So if I were taking in my classroom, I had a globe like this, I would walk all the way around. And as I did that, I would be spinning it the right direction, right? Now, if I wanted to go over here, can I change the tilt of the Earth? And at this point, if you had a gyroscope, that's when I'd haul out the gyroscope in my classroom, and I'd set that thing to spinning, and I'd see how easily or how difficult it was to change the position of the axis. You can't. Well, you can, but the Earth can't, all right? So this axis is always going to stay pointing in that direction. It doesn't make any difference where I go, all right? So over here, the axis is pointing that way. It is turning this way. How many turns has it taken for me to get from there to here if I'm, 1/4 of the way around? How many rotations has that been? 1/4 of a year, okay? And as I keep the axis of rotation in the same position, and I keep going all the way around, I can't do it right now. Again, the axis is still pointing to the north. It's still rotating the same direction. We go all the way around, okay? You might think I'm crazy for doing this, but I have method in my madness, all right? The axis stays in the same position. So how many rotations has it made when we make our whole trip? 300 Oh, you guys are so good. Okay. Now, most of us are pretty good with that. All right? But then we throw in that corker, the moon. All right? Now, it's very difficult to keep this straight in your head. It's going to be very difficult for your students. And it's going to happen more than once. That's why I'm here today. I'm going to give each of you your very own moon. Now, there's plenty of room back here. Let's douse the lights again. Okay. This is really important. Bring your diagram. Come on back here because we're If you don't see it, don't fake it. This is not the time to pretend. Same thing to tell your kids. If you don't see it, don't fake it. All right? Start with our moon, the sun. Now it looks pretty black, doesn't it? Yes. Okay, now put it in your left hand and rotate to the left and look at your moon. Do you see that sliver of light begin to grow? Yes. All right. Now, if it's nighttime, okay, the sun is going to be behind you. All right? Here again, it's the appearance of the lighted part that is the clue. All right? And keep going around. In 2 weeks' time, you're going to see a full moon. Okay? Keep going around from the full moon. Where does the shadow first appear? It appears on the left side. Shadow is on the different side. And come back around. Oh my goodness, my light is getting smaller and smaller and smaller and smaller, and it finally disappears. Okay?
Brenda, why don't you let them stand right by you? Assume they're right where you are. Let them, some of them can't see out here, but let them try it.
Okay, come on up this way. That's okay. It needs to be, you need to see it. Okay? You're going to drop a box of sand on the floor. I asked about the lamp back there. It would be better if we could admit it in total darkness. How'd your deal go?
40 people, wonderful. Really exciting.
Good. It helps? Okay. All right. The whole point, I don't think anybody ever talks about the phases of the moon these days. But I want to tell you, every time you go outside at nighttime, you're going to see the moon. All right? And you're going to stand there on the street corner and you're going to look at the moon and you're going to go, and you're going to be able to decide. Is it a moon that's getting bigger? Are you in the waning phases? Or is it going to be getting smaller? Or are you in the waxing phases? You can label these. You want to know the different phases of the moon? Do you ever use that in your classroom about a new moon, first quarter moon, full moon, last quarter moon, waning gibbous and waxing gibbous? I don't know how you pronounce it. All right? Gibbous? Pick away. Okay? The important thing for you and your students, okay, here again, pictures are one thing. Ask them about the moon that they see. Ask them about the rotation of the earth. If they can do this without having preconceived misconceptions. All right? You want to always relate it to their real world, and the discussion here was it would be difficult to get the kid to believe it. All right? Here again, this is a model. How is this moon different from the real moon? Well, a lot. They've seen pictures of the moon. It's not black, but it's pitted, right? How many of you ever tried to spray styrofoam or to make styrofoam a different color? It's really tough, and it's really infuriating, okay? The quickest way, this is, what do you put on the outdoor material it's a name. You keep iron from rusting with it. Rust-Oleum. This is black, flat black Rust-Oleum, all right? You get a baggie, a big baggie, a freezer bag. You pour half the can in the baggie. You put 6 of these little balls in there and you seal it and you scooch them all around. You open the baggie, you spear them with one of these sticks, and then you stick this in some place that'll hold it upright. All right? Very short, very little time wasted. That does drip. It does make a mess. You do it on newspapers. But to spray 30 of these things would take you forever. All right? And not only that, you'd breathe in all that stuff. Okay? So you pour in a baggie, squish them in there, let them soak in really good, then stick them down and let them drain. A simple way to do that.